Class 14, Ryacas on R interface to the yacas computer algebra system. Ryacas is a computer algebra system. Click here. What is computer algebra system? A computer algebra system, CAS, is any mathematical software. It's a mathematical software with ability to manipulate mathematical expression in a way similar to the traditional manual with hand computation of mathematician and scientist. So it is very convenient one. It solves problem as if you are using pen, pencil, and paper. Again, CAS, computer algebraic system, solves problems as if you are using pen and paper. You will understand better what I mean once we take a look at the examples. In order to use Ryacas, a computer algebraic system, you can take a look at this link or this link. Okay, but before you take a look at this one, you have to install Ryacas. So I want you to copy and paste the follow lines in R terminal line by line. So let's start R. So in R, install package. Let me start R again. R was stuck in the previous session, so I started R again. So paste, install. I'm installing Ryacas. Yeah, it is installing. It takes some time. Okay, good. Now let's copy and paste the second line. Library Ryacas. Well, it's working. Now next, I want you to copy and paste this line. Okay, and then copy and paste this line. And then copy and paste this line to test it out. Okay, good. It is working. I think it is working. Well, R in this piece is a bit slow. So let me just close this one. Okay, so I think this is enough. Oops, stop. Yes, stop. Okay, so next let's copy yacas expression. Okay, this one. Well, another warning message, but well, this is yacas expression factor x squared minus 1. So basically, what it does is that basically yacas and then expressions, and then factor of x squared minus 1 basically. So if we do x squared minus, if we do factor x minus 1, then it is the same to x plus 1, x minus 1, right? So it is a factorization. Exactly, it gave us the answer, factor, right? Expression, x plus 1, and x minus 1. That is yacas. You know, with given symbols, it does work as if you are using pen and pencil. Okay, it's a very powerful tool. Next, try the next one. It is the expression 1 is this one. So here, let me take a look at. So, well, express 1 is equation 1, expression 1 is basically x squared plus 2x squared, which is 3x squared. Here, expression 2, let's do equation 2 is 2, and then expression exponential some x0, some constant, and then expression 3 is 6 pi x. Expression 4 is expression 1, and then 1 minus sine of expression 3, and then divided by expression 2, something like that. And then we want to see which is expression 4, and we want to know simple form of expression 4, right? So here, yeah, where we have expression 1, expression 3, expression 1 goes here, and the expression 2 goes here, and the expression 3 goes here, and then this expression 4 would be very complicated function, but this yacas can do this work very well. So let's see. So copy and paste this 3 line in R. Okay, now let's do yacas expression 4. Well, yeah, so this is the answer. So this is the answer is basically looks like this. And then, yeah, so the answer is basically expression 4. So basically expression 4, this is same to 3x squared. And then, well, let me write down again. So we write one, which is 3 and x square 1 minus sine 6 pi x, right? 6 pi x, and then divide 2x3, right? So it quickly gives us compact expression for expression 4, right? Now I think we are ready to take a look at this one. So let's open this one. Yes, like us on R interface. Download here. Open folder and let's open this file. PDF reader. And then we have another file. And let's open download this one as well. Package Ryacas. So it basically this manual, it gives us the more detailed. Yeah, detailed one. Open folder. And now let's open this one. Get this one. Let's close the solve for differential equation. And minimize this one. And close this one as well. Okay. So there are many good examples. So this package, it is maybe a bit hard for you, but this is actually more easier. So let's open this one. Take a look at. So again, factor. Yeah. Expression 1. Copy and paste. Right? Copy and paste. And then go to R. Copy and paste the first line here. Well, then express 1 is, yes, it gives x plus 1, x minus 1. It is x squared minus 1, so it is the answer. Right? Now, we can evaluate. Now, we store this one as expression 1, and actually we can evaluate this expression 1, at x equal 4, then 5, 3, so it should be 15, right? So let's copy and paste this one, evaluation. So this Ryacas can do the evaluation, so we have answer 15, right? Now, it does differentiation, okay? It is the, we are basically d sine x, so basically it is, what we are trying to do is d sine x dx, right? And we know this is cosine x, right? And then, yes, we run this program, we have cosine x. And let's see whether this is true, okay? Yacas, take differentiation, right? Then, yeah, take differentiation sign, exactly, yeah, here, dx sine x, this means basically d sine x over dx, which is cosine x, which is this part, right? It's very convenient. Cosine x. Now another sim object. Okay. Here, if we put sim, then x is just expression. So x. Let's use this one. Then x is just x. It is the expression for x. And if we talk x plus 4, 3, then we have expression x plus 3, right? So this x, we can use x as a symbol from now on. Now, integration, it can do integration. Integrate sine x. So basically it does integration, right? It is integration of sine x with respect to x, and we know the answer is minus cosine x, and then plus some constant, basically plus some constant actually, because it is indefinite integral. Let's see whether it is true. Then integrate sine x with respect to x, then it is basically cosine x, minus cosine x over here, minus cosine x, and plus some constant, it is indefinite integral. Well, we can do x as a simple symbol xs. We can do this one, symbol xs, and then we type x, and it is the expression xs because we change x as symbol of xs, and this plus 4 should be, right, xs plus 4 because x is now xs. Now evaluate x plus 4, now x is xs. At x is 5, then 5 plus 4 should be 9. Yes, we have 9 over here. We have 9. Now we can also store x as a symbol like this. Okay. Now sample session. Now this one expression, right? This one expression of this one. Where this one complicated one, and we know the answer A323603. How about the fractions? We do yacas fractions. Then we have expression something like the 149 over 12. So if we use this Ryacas, we can calculate the fractions. We can work with the fractions as well. And the symbol of this one, again, right? It is similar one. Well, it doesn't work over here, actually. How about this one? I don't know why this doesn't. Yes, it perfectly work over here. So we sim and double quote, then calculate this one as the fractions. And we can do numerical evaluation expression. And then this numerical expression, minus 12 over 2 is minus 6. So it can calculate numerical evaluation. Right, minus 6. And then again, same, minus 6. Symbolic expression, we did this one. Actually, we did this one already. And then let's skip this part. skip this, but now it is differentiation. We did it integration. Now it is integration. Okay, now it is the definite integration. So xab. So integrate xab. Okay, so this one. So this one basically means integrate x. Okay, integrate with respect to x. Okay, sorry, it is not true. So it is x, so it means it is integrate with respect to x, so it is dx. And ab from a to b, which function we want to integrate sine x dx. And this is actually cosine b plus cosine a, which is actually cosine a minus cosine b, because integration of sine is minus of cosine. Let's check it. We can again copy and then paste. Done, right? Cosine, if we learn this one, cosine a minus cosine b. We're done. And then we can use the symbols and we can do the similar operation. Now expanding polynomials, x plus 1. Now here it is 1. If we express 1 plus x3, we know it is the x3, 3x squared, 3x plus 1, right? Let's see whether it does the work. Yacas expand. Beautifully it expanded, right? The correct answer. And the Taylor series expansion, okay? It is a Taylor series expansion, exponential x up to third order. We learn Taylor series expansion. So we know if we do the Taylor series expansion, then ex equal 1, and then x, and then 2x squared. Actually, it is the 3x third, 4x fourth, something like that. And then if we are interested in Taylor expansion up to this 3 part, up to third order, actually we need factorial over here, factorial over here, then it is this one, right? This is same to this one, third order. So let's learn this one. Yacas text Taylor series expansion up to third order. Yes, we got the answer. Yeah, third order. And then we this one. And then actually, this one, we Taylor series expansion this one, and we can, it's a pretty form. Well, this one looks not so pretty, and this one is more intuitive. Maybe you think this is prettier, but anyway, this is more intuitive. So you can see more prettier form, right? Here, you can see this TXP thing, this part is this one. So we call this over here, and we do the pretty form, right? Pretty form, then it is it is a pretty form. Yes, it is a pretty form. Yes, we have a pretty form over here, right? And then close. And then we have another latex form. Let's skip this one. Pretty form, and then other calculation. And we define n 10 plus 2, 5. So it is 60, clearly. And n equal n plus n is 120. So we do this thing. Set, well, we can skip this one, likewise skip this one. Okay. Then numerical evaluation, exponential 1, exponential 1, they do numerical exponential pi, yes, root of 12, 2, yes, you can do many things, so skip. You can, they are too easy, so I want to skip. Precision. Now rational numbers, expression, and the symbolic calculation, yacas this one, expression, and then skip. Now you can do complex number. I, this is complex number, image number I, so this is the, basically this is the I square. We know this is -1, right? So let's copy and paste on R. Yes, expression -1 over here, -1. And the 7 plus 3i, okay, 7 plus 3i, when we have a complex Cartesian, which is basically, well, we express like A, in high school we express A, no. We have A plus BI, we often express as AB, right? In Cartesian space. That's what it does. Right? And then conjugate. It calculates conjugate is of course 7 minus 3. And evaluate express 3i and then complex cut, it is the Euler formula, right? It is Euler formula. So basically it is the theta I is cosine theta plus I sine theta, which is cosine theta and sine theta, right? That's what it does. Yeah. So try. Done. Yeah, we have. You can change A, and then actually you can change A, and then express A plus A, Cartesian A, and then 0i. It is a bit strange, but yes, let me skip this. And I square minus 1, and we have this one, conjugate number. And then exponent 3i, we have this one. Okay? And if we use this percent, it returns most least value. So yacas, this one. And if you simply yacas percent, it does most least operation again. I need a double quotation. Double quotation percent, it does most least operation again. It records. So this one records the most least line, the percent operator. Okay, so you can skip it. And then standard form and pretty form. Yeah, it is the way of defining matrix. Matrix A, B, C, D. So list. Matrix B looks like this, and then to the many multiplication, and the pretty form A, which is like this one. So A, B, C, D. We have A, B, C, D in pretty form B. Here B is this one, and if we do the pretty form is this one. Yeah, pretty form A, B. Yeah, text form. Comment. So factorial, you can calculate factorial 40. Okay. And the Taylor expansion, we already know the Taylor expansion. And then this is the Taylor expansion at 0. So it's a Taylor expansion at 0. So it is basically Maclaurin series. And for arbitrary point A, we can do Taylor expansion at arbitrary point A. Then we have this one. So when A is 0, they are same, right? Another arbitrary point. We have inverse Taylor. We skip it, and actually it can also solve equations. Well, x 1 over x equal a, if we wanna solve this one, then it is 1 plus x over x equals 1 over a, which is 1 over x plus 1 equal 1 over a. So here 1 over x equal a 1 minus a, therefore x equal 1 minus a over a. We can solve this one easily, but Ryacas can do it even quicker, right? So solve x over 1 plus x equals a with respect to the x. Then, yeah, a lot of error, but still we got the solution. We got the solution over here. Now we solve x over here, then we have two solutions, x squared plus x equals 0, then solution is 0 and minus 1, and we got it. This is similar one. And then we can do numerical solution this way, and actually we can expand the polynomials, expand 1 plus x3, expand something like this, and you can actually simplify, well, this one, and then we can simplify y, symbol y, and then yeah, we can, it is straightforward, so let me skip. Y is symbol y, yacas this one, and then, well, this is expression, this is, we can simplify this one. If we simplify it, then we have this one. Now, analytic derivative, we learned this one already. Take derivative, integration, it can do integration. This is a bit complicated integration, right? Integrate x, this one, complicated AB, so yeah, we can use the symbols AB and then to the integration. And limit, it can calculate limits, right? Limit when n goes to infinity, this is the basically limit n goes to infinity, and then this is the 1 plus 1 over n to the power, we know this is definitely e, right? E to the power 1, right? E. So we know this one. So this is true. When limit, when h equals 0, then it is basically derivative of sine function. Derivative of sine, we know cosine, then it should be like this one. And the limit, we can do the same thing. Okay? And then variable substitution, we substitute this one. And then, yes, substitution, that's fine. And then we can solve ordinary differential equations. Yes. So ODE solve, well, it is a second order differential equation, and we know how to solve this one. And we solve it, then we have two exponential part because it is the real number. So yacas, if we run this one, let me again, yes, I don't know, there is some error in this here, sometimes R doesn't work properly, I don't know why. Yes, it does work, yes. So yeah, I have to type this one, and then, well, to take a look at it, so y2 prime equal 4y, solution is then y, solution this means c some constant e2x plus c some constant e to the minus 2x, right? I explained to you how to solve this one already. And then if this is minus, then now we have a complex number, right? It is the minus 2, right? So it is basically same to when y, right? So when y2 prime is now minus 4y, then we have complex solution. So in this case, y is basically, as I explained, c some constant e, and then minus 2i, right? Minus 2i, and then t, x, and then plus c228. Actually, x is before, but it doesn't matter. 2ix, right? But and then of course you can express this in sign. In the previous case, we solved this one as a sine 2x plus b cosine 2x, but and they are same, but Ryacas generate this first part. And then matrix, you can do matrix, right? And then we can define matrix, and then we can see the pretty form looks like this. And inverse, we can calculate inverse matrix. Inverse looks like this. Let's try, well, yacas. Let me try this one. And then yacas pretty form. Yes, we have something like this. And then inverse matrix. Inverse matrix. Where is inverse? Inverse. This is inverse matrix of E4. Looks like this one. And then we can take a look at pretty form of inverse matrix. So this is the so here, this is E4, and this is E4 inverse. Here it is called E4i. Because we defined E4i over here. Pretty form, and then inverse matrix and a determinant. We can calculate matrix determinant. Determinant E4, and then other miscellaneous factor unquote. We can see the answer without unquote, and character. We can see the character. I think this is all for our Ryacas, and I hope this is very convenient tool. So I hope you enjoyed this session for Ryacas on our interface to the yacas computer algebra system. Thank you.